a projectile um, with an initial velocity of 25 meters a second at 30 degrees to the horizontal. It passes building 1 and falls on building 2. The distance that it travels, the horizontal distance, that is to say, is 30 meters. The question is, find the time for it to reach the 30 meters from here to here. Notice this is also the time for it to fall on building 2, which means this is the time of the trajectory. You're asked to find the t30, so the first thing we do is we know that the x distance, is equal to 30 meters, but this is also equal to the velocity x times the t, where t here is the 30 meters. So all I have to do is substitute Vx being 25 cosine 30. Remember we said in class the 25 cosine because C for close, C for cosine, closing the angle. And if I'm opening, then it's sine. So in this case, what I found here is the Vx. I still have to multiply that by the time. Which gives me t30 meters is equal to the next question is find Ty max. Ty max happens at building 1. This is building 1, this is building 2. So the time to reach the maximum height occurs when Vy is equal to 0. When Vy is equal to 0, which is the final velocity at the top. So, but we know that the equation Vy is equal to V naught plus AT. Notice here that this is the vertical component of the velocity. So it's V sine initial velocity sine 25. We said when we're opening the angle here, we're going to open the angle to get the vertical component of the velocity. That will be your Vy initial. This is final velocity, and final velocity we said is equal to 0. So the equation becomes, this is 0 is equal to 25 sine 30 degrees, excuse me, this should be 30. Notice I put a negative here because we're going against gravity, so that's why it has to be a 9.81 and then multiplied by the Ty max. This gives me Ty max equal to Part C asks for the Y max itself. The Y max happens at building 1, also happens at the time of 1.274 seconds. That's the time to reach the maximum height. So we can take advantage of this opportunity and say that my Y max is equal to, given from the equation. Notice here I wrote G instead of acceleration because we know that the acceleration is gravity, so it's due to gravity. So my Y max is equal to v naught here is going to be again the vertical component of the velocity, which is 25. This is the time for it to reach the maximum height, which is the 1.274 minus, in this case, because we're going against gravity. Notice also logically, the initial velocity is very high, and as it's reaching its maximum height, it's decreasing and decreasing, decreasing. So I need to put a negative sign here because I know this quantity should start decreasing as we go upwards against gravity. Finally, the question asks you to find the height of building 2. To reach the height of 2, it took the time to reach the 30 meters. This time, of course, is a simultaneous, or rather a common time between the vertical and the horizontal motion. So the time it took to reach building 2 would be, or is, the 1.386 seconds. So let's solve for that. Y for building 2. Well, notice that building 2, really the distance is so close to building 1, because to reach building 1 it took 7.961, in here 7.90, difference really 0.06 of a meter. So let's continue. Now, although this is not in the question, but assume building 2 did not exist. What is the maximum range the stone would have traveled? In other words, I want the full range. Full range happens only when you do not have any obstacles in between, and full range happens when you're talking about basically this would be the full range. And the equation of the range is r squared is equal to v squared sine 2 theta over g. Well, theta is 30, so multiplied by 2, that would be 60, divided by 9.81, and that would give you a range of 55.17 meter.